In this video, we're going to learn how to properly write formulas for binary ionic compounds when given the IUPAC name. Remember, these are formulas for things that are non-transition metals. And if you remember from our previous video when we talked about chemical nomenclature, we talked about the different rules to name ionic compounds. The first way is to just name the cation ion, which is the positive ion, and then name the anion while changing the ending to "-I". So this example, the name would be lithium oxide. So let's start by talking about how we can write ionic formulas from our ionic name. So we have this example here, magnesium bromide. The easy part is just indicating what elements we're talking about. So we know magnesium, that's our metal, it's going to go first, and the symbol is Mg. And then we have bromine, and that is just Br, and it's a nonmetal, so your nonmetal always goes second. The hard part is figuring out how many subscripts we need to write. How many ions of each do we have? All right, that's kind of tricky. But what I want you to remember is when you're writing a formula, you have to make sure that you have proper subscripts, and they have to be included. And one key idea is your subscripts, what they are, is they just indicate how many of each ion is needed. So in order to properly write the ionic formula for magnesium bromide, we have to figure out how many magnesiums we need and how many bromines we need. So how do you tell how many of each subscripts do you need, right? So we can start by indicating the charge of magnesium and indicating the charge of bromine. And you can remember the way that we learned how to do write our charges was just try to indicate, we know that our metals lose electrons in order to become like noble gases, so they're going to have positive charges, and our nonmetals, they tend to gain electrons, so they're going to have negative charges. So one key idea is whenever you're trying to figure out how many subscripts we need of each ion, the net charge of any ionic substance has to be 0. And what that means is it has to be neutral. So the charges kind of have to cancel each other out. The next piece of information is just add additional ions until the charges add up to 0 and basically cancel out, ensuring that the net charge is neutral, aka is going to be 0. So let's start by modeling our example of magnesium and bromine. So we know that we're starting with one ion of magnesium and it has a +2 charge. And we also have one ion of bromine which has a -1 charge. So if you take a look over here, we indicated that we have one magnesium and one bromine. So now we just need to figure out, do these charges add up to 0? So we know the charge of one magnesium is +2. And the charge of one bromine is -1. When we add that together, it equals +1, which definitely does not equal 0, and it's not neutral. So therefore, we need to add additional ions until the charges add up to 0, aka canceling out and making sure the net charge is neutral. So let's start by just adding more magnesium. When we do that to this scale, we see now that we have 2 magnesium ions and just 1 bromine ion. Again, we want to make sure that the charge equals to 0. So since we have 2 magnesiums, this +2 plus another +2 is going to give a total charge on this side of +4, right? Our bromine, since we only have one of them, is still going to have a charge of -1. When we add these together, a +4 plus a -1 is going to equal a total charge of +3. That definitely is not 0. It's not neutral. These charges did not cancel out. So we're going to have to do something else now. So instead of adding more magnesiums, let's see what happens if we add more bromines now. So you can see in this example, we have 1 magnesium and 2 bromines now. We want to see if the net charge equals 0. So take a look at this. Since we only have 1 magnesium, and that magnesium has a +2 charge, and we have 2 bromines, so this -1 and this -1 equals to a -2, you can see that this +2 cancels out with our -2 and ultimately leaves us with a charge that is neutral, aka the charge cancels out and adds up to 0. So this would be the proper subscripts that we need. We need 1 magnesium for every 2 bromines. The last key idea that we need to talk about is what happens once we figure out the subscripts. We know that we need 1 magnesium for every 2 bromines. The last key idea is that charges and subscripts of 1 are typically not shown. We know that we have 1 ion of magnesium, but technically we don't even need to write that because they're usually not shown. So what that means is your last bit and your final answer is going to look like this, MgBr2. And that is our example for magnesium bromide. The last thing we're going to talk about in this video is just common charges of ions. We know that we can write our electron configuration and talk about transfer diagrams and all those things to figure out charges of magnesium and bromine. But there is an easier way. You can just take a look at our periodic table and know that since metals tend to lose electrons, they're going to be positive, and our nonmetals, since they tend to gain electrons, they're going to be negative. So if you take a look at this column over here, all the elements in this column are going to have a positive 1 charge in order to gain a noble gas configuration. The second column is going to have a positive 2, and then this column, aluminum, is going to have a positive 3. And then we're going to take a look at our noble gases. We know noble gases really don't have a charge, so we're going to say that their charge is just 0. This column is just 1 away from a noble gas having a negative 1 charge. This column is going to have a negative 2 charge, and lastly, this column is going to have a negative 3 charge. We didn't talk about elements here and here because their charges can differ depending on what problem we're talking about. And that concludes our video on ionic formulas. Take a look at a quick recap. Thank you for watching.